Right, question 3. Once again I can see some parallel lines through here. That might be useful. And this is very much looking like a similar triangles question too, with the smaller triangle inside the bigger one. Right, so we're asked to find angle C, which is this angle here. We've got 125 here, so I could work out this one round here. A is going to be 55 using angles on a straight line. We have a small triangle in here, so 180 minus those two will give me 81 down here. And then using our parallel lines, corresponding angles, C will be 81 as well. There are other ways to do it. So we could have used co-interior angles to find B, and then we could have used angles in the big triangle to find that one. I'll write down the one I've found. So I started by finding angle A equals 55, and that was angles on a straight line, sum 180. Right, finding angle D using angles in a triangle will be 81. And then of course corresponding angles down the bottom here. So finding angle C equals 81 as well, and that was using corresponding angles in parallel lines are equal. Right, part 2. Now I don't actually want to lose the triangle on this one. We'll just erase those angles for the next part. So you'll have to imagine that I've brought up part 2, which says find the length marked X in the diagram, explain your method clearly and give geometric reasons. So I'm going to use similar triangles. I'm going to begin by drawing the big triangle outside here. You have to imagine that that one is the big triangle. It has one side of 15. It has this side of 18. And then the small triangle, will just highlight that. Inside there is the smaller triangle with a side of 10 and X. Now to be able to use similar triangles, we need to prove that the angles inside this small triangle are the same as the angles inside the big one. So we know that angle C and D, so there's C there, that's angle B, and there's the 44. We know that angle C is the same as angle D from corresponding lines. C is angle D, corresponding angles and parallel lines are equal. And we also can see that B and A will be the same. Once again, corresponding angles. Angle B equals angle A. Corresponding angles and parallel lines are equal. And clearly, they both have an angle of 44. So, therefore, both triangles are similar. They have the same angles, which means their sides are in the same ratio. I like to think of it as one is an enlargement of the other. So this big triangle is an enlargement of the small one. So thinking about how much it's been enlarged, I do this by looking at an enlargement factor. There are other ways to do it using ratios of sides. It's been enlarged 10 to 15, so I call it the enlargement factor will be 15 divided by 10, which in this case is 1.5. So the bigger triangle is 1.5 times bigger, the sides, than the small one. So that means I have got x times 1.5 has given me 18, so we need some working. Which means x is going to equal 18 divided by 1.5, which gives us 12 centimetres. You might want to do it with ratios of sides as well, which in effect is exactly what I've done. Right, some circle geometry, but also with parallel lines through here as well. Show that angle J is 120. If this is 120 in here, then X is clearly 240. And I can see that J is going to be half of that, which is 120, and that comes from the angle at the circumference being half the angle at the centre, and they're off the same arc. The arc that they're standing on is this one. Here's the angle at the centre from those points, and here's the angle at the circumference from the same point, so this angle will be half of that one, and we've proved it. So we need to start by saying angle X equals 240, and that's angles at a point sum 360. Therefore angle J equals 120, and that was using angle at circumference is half the angle at the centre off the same arc. Some people use the word subtended, or the same arc. Right. Part 2 says to find the size of angles H and K. So if I stay up here still with the diagram, you can do the working down below. We've got parallel lines here, which means J and K are co-interior, so K will be 60. So we can say angle K equals 60 degrees, and that's using co-interior angles in parallel lines are equal, not equal, they sum 180. And similarly with J, with H, angle H equals 60, because it would be co-interior with the 120 down here. Sum 180. Right, and on to part 3, which is quite a difficult one and also difficult to explain on a video. Make sure I get it right. Explain how we know from parts 1 and 2 that the quadrilateral on the previous page may actually be a rhombus. So this is the same diagram as the other page. We know that that's 120, that's 120, that's 60, and that's 60 as well, and here's my parallel lines. So for something to be a rhombus, we need to first show it's a parallelogram, that all the sides are parallel. We'd need to show that HX and JK are parallel as well, which clearly they are, because those two angles would be, if they're parallel, then this angle and this angle would be in fact add to 180, so they must be co-interior between that side and that side. So we can say that HX is parallel with JK because coint angles sum 180, and since HJ is parallel with XK, this shape is a parallelogram. Right, now to show it's a rhombus, we're going to need to show that all four sides are the same size. Well, it's clear that HX is the same size as XK, and that's because they're both radiuses. This is a radius and this is a radius. So we can say that HX is the same length as XK, because they are both radiuses, or radii would be the plural, but radiuses, they'll know what you mean. Radii is the correct plural. Right, so if you have a parallelogram and two sides in it are the same size, then the other two must be as well. Parallel sides in a parallelogram are the same length. Parallel sides in a parallelogram are the same size. So that's going to mean that all four sides, so HX must be the same length as KJ, and XK is the same length as H. It's J at the top, isn't it? Hence the shape is a rhombus, because in a rhombus obviously all the sides have to be the same length.